Okay. All right. Before you leave 6 hour, just get the components of an exponential function. I'm a little scared that this is one you're going to not remember so much from last year. I will tell you that we are going to do this chapter 3. Exponential is real big, but at least input 2 to the 0 is 1. Remember, 2 to the 0 is 1. Anything to the 0 power is 1. 2 to the first is 2. I don't know why I'm writing these. And then 2 to the negative first, remember the negative exponent rule. It flips. So 2 to the negative first is actually a half. Then 2 to the negative second, 2 to the negative third, 2 to the negative third is 1/8. This is getting annoyingly closer and closer to 0 as I plug in those negatives. So human beings draw a horizontal asymptote to show that behavior. We draw it. The asymptote doesn't exist for the graph. We just say, okay, we get it. We get that as I keep plugging in negatives, these y's get infinitely smaller but never get to be 0. So when I look at an exponential, I'm going to find out where these 3 points end up. Where does the asymptotic behavior start happening? Even when the bell rings, you can walk out. Don't put your stuff away, though. I'll feel offended. And I'll tell you where this point ends up. Yet again, it's the 0 of this. But I do want to make sure you understand something. See the 3 minus x? Do you see it? Do you see it? You want to pull out a negative and make that x minus 3. And then we can actually, after I show the picture, understand that that negative 1 on the inside is a y-axis reflection, a negative on the inside of the function on the variable. But let's go ahead and plug in 3. 3 minus 3, the original is 0. 2 to the 0 is what, everybody? What's 2 to the 0? No one will leave my 6 hour until you answer what's 2 to the 0. 1. What's 1 plus 4? Boy, he got intense there. 1, 2, 3, 1, 2, 3, 4, 5. You okay over here? Looks like you're like someone's like you're in a boxing match. Your head keeps flailing back and forth. All right, and then what I want to do is 2 and 4. Hey, what's 3 minus 2? You're not leaving. What's 3 minus 2? 1. Everyone's rolling their eyes. Oh, this is too much on the first day. What's 2 to the first? 2 plus 4. I got it. 2 comma 6. 1, 2. Oh, this is higher. Interesting. Look at these 3 dots. A little bit different what these 3 dots are compared to the 2 that I have there. 4. 3 minus 4 is negative 1. 2 to the negative first is a half. 1/2 plus 4 is 4.5. Okay. Now we start getting that approaching behavior. And now I get it. If the family parent has an asymptote at y equals 0, then this new function, the asymptote was moved up to 4. And now I see that the graph is going in a different direction. That's because it was reflected over the y-axis. See this graph over here? Compared to this, that's a reflection over the y-axis, and that's the direction that one's facing. All right? And then it is 3 to the right, this important point that used to be the raised to the 0 power point. Okay, so anyway, you end up with a y-axis reflection. That's what that negative on the inside is, what we just discovered. And then really it's just 3 right and 4 up. And then the domain is all real numbers. The range actually is limited to that asymptote. And did we ever reach 4? Yes or no? What does the asymptote say? Did we reach 4 or not? Not. That's a parenthesis, not a bracket. That's the difference with that one. All right, we fit that in all the classes. Even yesterday, I did not do this one, but let's just analyze it at the end. This is going to be reflected over the x-axis. This is going to be shrunk vertically, move 3 left and 4 down. And then you could go from there and make a sketch of it to make sure that happens. The point that I would move 3 left and 4 down is what I would consider the vertex for the V. And then you can go from there. So pretty simple standard stuff there. All right. And hopefully we get that good.